Our question says, Morris rents a helium tank to blow up balloons for his birthday party. If his balloons are sphere-shaped and he wants them to be 12 centimeters wide, how much air does it take to fill the balloon? So as I read the question, I do notice that it says that the balloons are in the shape of a sphere, and he wants it to be 12 centimeters wide, and we want to know how much air it would take to go inside. So since we're talking about what's inside the balloon, that is volume. So I'm going to draw myself a sphere-shaped balloon. And it says that it is 12 centimeters wide. So I'm going to label that on. That would be the diameter. So when we talk about air, that is inside the shape, and that is volume. So the volume of a sphere is 4 pi r cubed divided by 3. So volume is 4 pi r cubed divided by 3. So this measurement here is actually the diameter. The radius goes from the center to the edge, which means this would be half of 12, which is 6. So my volume is 4 pi times 6 cubed. So that means we multiply 6 by itself 3 times. So 6 times 6 times 6 divided by 3. So I'm going to calculate that. So 4 times pi times 6 times 6 times 6 divided by 3 is 904.77. I look at the next digit, it's an 8, so that's going to push it up to be 78. So 904.78, and that is centimeters cubed because it's volume, and I'm going to put a dot to show that we rounded. Now, since this is a question about Morris and his balloon, I do actually need to write a sentence. It says, how much air does it take to fill the balloon? I'm going to say, therefore, it takes 904.78 centimeters cubed of air to fill the balloon. All right, our second part says, if the helium in the tank is compressed to 20% of its normal volume, how much of the helium would it take to fill one of the balloons? So compressed is when something gets shrunken down. So when they put helium in a tank, they put it under pressure so that they can fit more in there. And then it also means that when you release the valve, it wants to come out. So we've got 20% is what it's been reduced to, and we want to know how much helium it would take. So I know that it takes 904.78 centimeters cubed of air. So I want to know what would that be if it was helium from the tank. So we haven't done a ton of percent, but we're going to give it a try. So I want to find 20% of 904.78. So I'm going to take 904.78, and then I'm going to multiply it by 20%. Now 20% means 20 out of 100. So I'm going to multiply by 20 and divide by 100. So 904.78 times 20 divided by 100 is 180.95, but the next number is bigger than 5, so that's going to push that up to 96. So 180.96. And that is centimeters cubed. And I rounded that so it gets the dot. So I'm going to say, therefore, it takes 180.96 centimeters cubed of helium to fill the balloon. All right, the next part of the question says the tank is shown on the right and is 30 centimeters wide and 90 centimeters tall. How many liters of helium can be stored in the tank? So we're doing helium, we're not doing air. And it says that it is 30 centimeters wide, 90 centimeters tall. So this is 30 centimeters wide, and from top to bottom all the way is 90 centimeters tall. So we want to know how many liters of helium can be stored in the tank. Because it's 3D and because we're talking about what's inside the shape, that is volume. If we were talking about the metal made to make the tank, that would be surface area. So, but it's the inside, what's inside the shape, so that is definitely volume. So, this is not one of the shapes on our formula sheet. It is, I believe, a combination of 2 or more of those shapes. So I do see there are circles involved, which makes me think it needs to be a cylinder, a sphere, or a cone. I definitely think the bottom part is a cylinder, and then I think that top little part up here, it doesn't meet at a point, it's a dome, so I think that's half of a sphere. So I think this is a full cylinder and half of a sphere. So I can calculate the volume of a full cylinder, the volume of a half a sphere, and then add them together, or I could try to make a formula using both parts and then just use the one formula. I like to do it in 2 parts. So I'm going to do the volume of the cylinder and then the volume of the sphere. Okay, so for the cylinder, the volume of a cylinder, according to our formula sheet, is pi r squared h. It's right there. It is a full cylinder from top to bottom. We're not doing half of a cylinder or anything like that. And while there are parts of the cylinder that are inside the shape, volume is all about what's inside. So I'm not taking anything out of that formula. We only remove parts from surface area formulas. Because there's a side that's inside, I don't really care. We're calculating the inside, right? So we're interested in the whole thing, the whole cylinder. But for the sphere, that is not a full sphere. It's actually only half of a sphere. So my sphere, the formula for volume is 4 pi r cubed divided by 3. So I'm going to do 4 pi r cubed divided by 3. And then I only want half of that, so I am also going to divide that by 2. Okay, so let's try filling in some of our dimensions here. When I go to do the volume of the cylinder, the radius should be from the center to the edge. So the whole thing is 30. Half of 30 is 15. So the radius here is 15. And then for the height of the whole thing is 90. Now the thing about circular shapes is that the radius goes from the center to the edge of the circle. It doesn't necessarily have to point this way. It could point that way. It could point straight up. It could point straight down. So if this is pointing straight up, this is 15, which means the height of just the cylinder is 90, take away 15, which is 75. So the height of our cylinder is only 75 centimeters. Okay, so our volume for the cylinder is pi times r, the radius, that's 15. Squared means I do it twice. And then times the height, which we said was 75. So pi times 15 times 15 times 75 is 53,014 point. Now I have 37. The next number is bigger than 5, so that's going to be 38. And that should be centimeters. And it is volume, so cubed, and I rounded, so I put approximately. For the sphere, I have 4 pi. The radius is 15, and it's cubed, so I multiply it 3 times, and then divide by 3. So if I calculate 4 times pi times 15 times 15 times 15 divided by 3, I get 137. But what did I forget? I forgot about the divide by 2. So I need to divide that by 2, which gives me 7,068 I got 5.8. The next number is a 3, so I leave it alone, and it's going to stay 5.8. And that is centimeters cubed. Okay, so if I want the total amount of helium, I'm going to take the cylinder, I'm going to add the little top dome on top, so I'm going to add the two together. So to get my total volume, I'm going to take 53,014.38. I'm going to add 7,068.58 to get 53,014.38 plus 7,068.58. Oops, wrong number. Gives me a grand total of 60,082.96 centimeters cubed, approximately. I wrote approximately because I rounded the original answers that I just added together. So how many liters of helium will be stored in the tank? Therefore, wait a minute. That's not liters, that's centimeters cubed. Now, when we were doing conversions, and I don't know where my conversion sheet went, we learned that 1 liter is 1,000 cubic centimeters. So I need to do a little unit conversion here to help me figure out what that would be in liters. I'm going to cross out my therefore. We're not ready for that yet. So I'm going to set up a little ratio. We know 1 liter is 1,000 cubic centimeters. So if I have 60,082.96 cubic centimeters, I want to know what is that in liters. And we're going to make a little proportion out of this and then cross multiply to solve. So 1 times 60,000 and all that is 60,082.96. That equals 1,000x. And then if I divide by 1,000, I get that it is 60.08 liters. So I'm going to say, therefore, 60.08 liters of helium, oops, I missed the U, fits, nope, yep, in the tank. Okay, our last question says, how many balloons can you fill with helium from this tank? So I know that there's 60 liters of helium, and I know that a balloon takes 180.96 centimeters cubed of helium. So since this is in centimeters cubed, it makes more sense to use my centimeters cubed. So I'm going to take my 60,082.96 centimeters cubed. I'm going to divide it by 180.96, which is how much one balloon is. So I'm going to take this. I'm going to take that number and divide it by 180.96, and I get 332.02. Now, am I going to fill 0.02 of a balloon? I don't think so. So I'm going to say it's approximately 332 balloons. So therefore, you can fill 332 balloons.